How are we doing, everyone? We're looking at page 339, exercise 9.3 there. We'll do question 1, maybe parts 1 and 2. What we're looking at here is finding the sum of an arithmetic series, okay? So if you can open your log tables, first of all, to page 22, and I'll just draw your attention here to these two formulas here. This is the one we've really been saying Tn is dn plus c. We've been ignoring this formula, common difference plus 0th term, but that's an alternative formula you can work with. I might discuss it at a later point in class. This is the sum of a sequence, okay? So sequence is where you're saying, in this case, 1, 5, 9, 13. A series is when you're adding them together, okay? And this is the formula that we're going to use. I'll tell you how that formula is derived in a minute, but we'll just start with using that formula. So question 1, part 1 is 1 plus 5 plus 9 plus 13. Now you can probably spot here, you're going up in 4s, okay? So that is your either your first difference or your common difference, and that's D is the notation that they're using there in the log tables. And then they don't talk about 0th terms, they talk about the first term. So A is the first term in a sequence. Okay, so for us, A is 1 and D is 4, and we need to be able to use this formula, so we're going to follow their notation. The sum of n terms then, given by our formula, n over 2 times twice A. This is the formula in the log tables here. Okay, well, twice A for us is 1. Plus n minus 1 times D, where D is 4. Okay, that gives you n over 2 times 2 plus 4n minus 4. And if you were tidying that up even more, you might say, well, 2 take away 4. So that's n over 2 times 4n take away 2. And you can even half that. It's n times n take away 2n take away 1. Okay, that's dividing top and bottom by 2. That's your general expression. Okay, if you wanted to say what's the sum of the first 3 terms, you'd say 3 times 2 by 3 is 6 minus 1. Okay, so that's 3 times 6 minus 1 is 5, 15, the first 3 terms. Well, look, 1 plus 5 plus 9, if you add the first 3 terms, you're getting 15. Okay, they've asked us for the sum of the first 20 terms. So that means just plug 20 into your formula, 20 times twice 20 minus 1. Okay, that's 20 times 40 take away 1 is 39. And that's 60, 78, 780, is it? Okay, so that's how you'll do these type of questions. Okay, try part 2 yourself there. Pause the video, see if you can do it. Right, so A is 50, first term. Common difference, you're going down in 2 with each step, so it's negative 2. Plug that into your formula. For general n term, you get n over 2 times twice 50 is 100, plus n minus 1 multiplied by D is negative 2. Okay, and tidying that up, n over 2 times minus 2n plus 2. So it's 100 plus 2 is 102. And then minus 2 times n is minus 2n. Dividing through by 2, you get n times 51 minus n. Okay, that's a common top and bottom. You've got a common 2. And then S20. Again, it's always good to check, actually. Does it work for like a low number? So pick 3 or 4. If I plug a 4 in there, I'm going to get 4 multiplied by 51 minus 4 is 47, is 160, 188. Okay, so check my first 4 terms. Do they add up to 188? Well, there's 98 plus another 84, 86, sorry, 90, and 98 is 188. Yeah, so it does work. So just that you know that it works, it gives you confidence you've got the right answer. S20 then is going to be 20 times 51 minus 20, which is 20 times 31. And that is 620. Now, where does the formula come from is the next question that you might be wondering. Okay, it's all well and good to be able to use it, but where does it come from? Okay, well, if I take a nice simple example like the term rule is 4n plus 1, and I want to say, well, what's the sum of all of those rules when I add all of those terms together? Well, the first term is 2, okay? It's not, excuse me. First term is 6. You plug a 1 in there. Okay, and you plug a 2 in there, you're going to get 8 and 2 is 10. You plug a 3 in there, you're going to get 14. You plug a 4 in there, and so on. In general, the term tn is going to be given by, now let's use the book's notation here, or the table's notation, which is that it's going to be twice, you know what, pause this for a second. Okay, so using the book notation, our first term here is 6. Our common difference is still 4. That hasn't changed. So 6, 1 4 added here in the second term, 2 4s added here in the third term, 3 4s in the fourth term. You can imagine in the nth term, it's going to be the first term plus n minus 1 times your common difference. How many 4s have you added on? Well, there's n minus 1 of them there, okay? So when it was third term, it was 2 4s, you added on to 6. Okay, and that matches up with this a plus n minus 1d formulation that they use in the log tables. The previous term before that will have been 6 plus n minus 2 times 4. And in finding this formula, we reverse it. We'll say, well, let's play it backwards. If I put the 6 over here, okay, the next term 10 I'll put here. And if I work backwards, then I'm going to skip that. But the second last term here, I'm going to put in under here 6 plus n minus 2 times 4. And in here, I'm going to put the last term 6 plus n minus 1 times 4. Okay, now all I've done is I've said this is another way of adding up all of the terms. You can add them up forward, 6, 10, 14, and so on. Or you can add them up backwards, 6, 10, 14, and so on. There's my second last and my last, okay? So we're only going to look at the first, second, second last, and last terms. That's on the bottom, and on the here, first, second, second last, and last. Look what happens if I add these together. I get twice 6, okay? And I'm leaving that as twice 6 and not 12 for a reason, plus n minus 1 by 4. Add here together. Now, I should have written that as 6 plus 4, actually, instead of 10, because look, you get twice 6, and then you get n minus 2 4s, plus another 4 makes n minus 1 4s. And that happens over here as well. I've changed that to a 6 plus 4 as well. Okay, 2 6s plus n minus 1 4s. Okay, and that's going to happen everywhere you do this. If you decided to extend this to 3 and 4 and 5 and n minus 2 and then tn minus 2 and tn minus 3, you'd see the same pattern. You always get 2 6s plus n minus 1 times 4. Okay, so why am I doing that? Well, it's the same, isn't it? Every single time it's the same. And how many of them are there? There are n of them. So if I want to add this all up, I can say, well, if I add these two together, I get twice the sum of this sequence is going to be n multiplied by this thing, twice 6 plus n minus 1 4s. Okay, n minus 1 common differences. Now, that is explained kind of in a fully algebraic way on page 335. Hold on a second and I'll find it for you. There it is. There. So I'd encourage you to go and have a look at that, or pause the video or look in the book and just read through it. But it's the same idea. You get that twice the sum of all of these terms added together is given by this expression here. And then the last step is you divide through by 2. And there's our formula that we've been seeing in the log tables for the sum of an arithmetic sequence. Okay, so we'll get back to working on the questions. So we're looking at question 6 now, and it uses this sigma notation. So we'll just have a look at what that means. The sigma notation means the sum of all of the numbers of this form where r has a value between 1 and 6. So what does that mean? Well, when r is 1, this number is 3 times 1 plus 1. That's 4. And it's the sum of, which means add them together. When r is 2, this is 3 times 2, 6 plus 1 is 7. Okay, when r is 3, this is 3 times 3 plus 1, which is 10. You can see this is first term a, common difference 3. When r is 4, 3 times 4 is 12 plus 1, that's 13. When r is 5, it's going to be 16. When r is 6, it's going to be 19. Okay, and that's as far as you want to go, 19. Now, you can go to your calculator, you can add all these up. This is a really simple example, so it's not a hard thing to do here. In general, though, this is our sigma notation. We have a equals 4. Sorry, this is our sum of a arithmetic series formula. A is 4, our common difference is 3. So Sn is going to be given by n over 2. Now this is 6, 1, 2, 3, 4, 5, 6 terms. So we should actually say the sum of the first 6 terms, 6 over 2 times twice a, which is twice 4, plus 6 minus 1 times our common difference of 3. So that's going to be 3 times 8 plus 5 threes is 15. That's going to be 23 times 3 is 69. Okay, I'm going to ask you to do maybe part 2 and 3 yourselves. And I am going to wrap up with question 9 there, which says the third term of an arithmetic sequence is 18 and the seventh term is 30. Find the sum of the first 33 terms. So what we're looking at is back to the terms. The third term is 18. So we're back to our Tn is, let's say, an plus b, or I think I might have been using d for common difference, dn plus c, I think, in the last video. So let's stick with that. dn plus c. Okay, so t3 is d times 3 plus c is 18. Okay, so 3d plus c equals 18. T7 is d times 7 plus 3, and that's 30. So that's 7d plus c, I don't know where that 3 came from, plus c equals 30. So simultaneous equations on these two, 7d plus c is 30, 3d plus c is 18. Subtract those from each other and you're going to get 4d plus 0 equals 12, so d equals 3. And once you know that d equals 3, come back up to either of them. That becomes 3 times 3 plus c equals 18, so you get 9 plus c is 18, or c is 18 minus 9, so c is 9. Okay, so Tn is given by 3n plus 9. Okay, so when we want to go and find the sum, we need to know two things. What's the first term? What's the common difference? Well, the common difference we know is 3. The first term, if you plug a 1 in there, is 3 times 1 plus 9 is 12. Okay, so you're going to go along and do Sn then with the same formula that you've done before. Okay, I'm going to ask you to finish that question yourselves now, as well as finish question 1 and question 6. If I can just draw your attention to one thing in question 6 before we finish. Where they've said here the sum between values of r of 0 to 5, well, that's still 6 terms. R equals 0, R equals 1, R equals 2, R equals 3, 4, and R equals 5. That's 6 different numbers that you need to work at. So just don't make that mistake. That's still the sum of 6 different terms. It's just between 0 and 5 instead of 1 and 6 like it was there. Okay, best of luck with that, and I'll assign other work separate to the video.